Okay.
Alright, so today I'm going to start by telling you what we're going to do. We have 2 bottles that are filled with water. 2 of the bottles are dyed blue and 2 of the bottles are dyed red. 2 of these bottles contain hot water and 2 contain cold water. So can anyone guess which one contains the hot and which one contains the cold? Yeah, Dakota?
The blue one is cold and the red one's hot.
Okay, yeah. I think that sounds like a good idea. Anna, will you come see and feel and see which one has the cold and which one has the hot? See if Dakota's prediction was right.
Okay, this one does feel pretty hot, so I think he was right.
Okay, yeah, so Dakota was right. All right, can anyone predict what we might do with these bottles? Cold and hot water?
Mix them together, maybe.
Maybe we will. We may not purposefully pour them into one another and mix them together, but we might do something similar to that. What I'm going to do is, for this one, I'm going to place the red bottle on top of the blue bottle with the caps off. And then for this one, I'm going to place the blue bottle on top of the red bottle, and then we'll kind of see what happens. Can anyone guess what might happen, or what?
It might turn, I don't know. Let's see. Is the water the same?
Is the water the same? Yeah, the water in the blue container, they're both identical, and the water in the red containers, they're also both identical. So what do you think, Anna? What do you think might happen? What do you think will happen when I put the red on top of the blue?
Well, we know hot air rises.
Right? Dakota, what do you think might happen when I put the blue on top of the red?
The blue's going to go down.
Yeah, maybe so. Okay, so you think the one with the hot water on top, do you think that those 2 are going to mix together?
Probably not.
Probably not. Dakota? Do you think the hot water on top, do you think they'll mix together? What do you think? What do you think?
I mean, why not?
You
Right.
think they will mix together?
Yeah.
Okay, maybe a little bit. But you think this one will? You think these 2 are going to mix together? The cold's going to mix with its on top? Justin, what do you think? Let me ask
I think it's going to balance out.
Let me ask y'all this. What do you know about cold water as compared to hot water? What's the differences between cold water and hot water?
One's cold, one's hot.
Yeah, what else?
The molecules in the cold water aren't moving as fast as the molecules that are in the hot water.
Right. And so what do we call that? A word that starts with D. We've talked about before.
Oh, I remember learning about this. That's density.
Okay. Well, let's just do the experiment and then we'll come back to that. Let's just hope this works.
What was it, teacher?
Let's just hope this works.
Oh, you've never done this.
Practice makes perfect, right? All right, one more time, Anna. Tell me what's going to happen when I remove this card.
They're going to switch places.
We're gonna switch. Water's gonna stay there. All right, Dakota, tell me what happened.
Well, it kind of has, it looks purple right here, and
You can still see a little bit of the purple at the top.
yeah, it looked like the red was going like here, but the blue might have been, I don't know. There was a big mixture in the middle right there.
Maybe a little bit of mixture.
Right, yeah, about right there.
All right, we'll clean that up in a minute. All right, Justin, what do you think about the blue going on top of the red?
I think the opposite might happen.
Think so?
Mm-hmm.
Do you think it's going to happen any faster, or do you think the mixture is going to be any different, or do you think it's going to be about the same?
I think as far as the reaction goes, it'll be the same speed, but as far as what happens precisely, probably the inverse of what happened previously. Or that was quicker, wow.
So whereas this mixture was kind of only happening right here in the middle, not really much up top or down below, this was kind of all mixing together.
Oh, wow. Look at it. It's black.
Um, Okay. All right, so we're going to call this a convection cell. So this is our convection cell, these two bottles that are together. What do you think affects the speed that the liquids mix together? In other words, I want you to complete the following statement in your journal, and we'll talk about it tomorrow. So the speed of mixing is proportional to the blank. The bigger the difference in blank of the two liquids, they will mix together. So, okay, that's written on the board for you. Not really, but it would be. So, fill that statement out in your journal, and then we'll talk about that tomorrow. So what if there was no temperature difference? What if they were the same temperature, the one on top wasn't cold, the one on the bottom wasn't warm? What do you think would happen?
If they're the same, they would just stay in the same place.
You think they would stay in the same place? Okay, so at the beginning, someone said that heat rises. Now that we've done the experiment, what might be a better way to explain what happened instead of just saying heat rises?
Maybe it would be best to say that the denser cold water falls, and because the hot water is less dense, it gets pushed up.
Okay, so Nakota's saying the denser water, when the denser cold water was on top, it moves down and pushes the hot water up. I think that's good. I like that explanation, but we'll come back to that tomorrow. So I have a few more questions for you guys, and I just want you to record them in the notebook. They're on the board also, but I'll go ahead and read them aloud. So number one, what does the word displacement mean to you? Just write that in your notebook. Number two, why does a given volume of cold water have more mass than the same volume of hot water? And so let's think about ice frozen on top of a pond. Think about a pond and there's ice frozen on top of it. Let's answer this one out loud. Is ice more or less dense than liquid? Less dense. Okay? Maybe so. But what happens when the ice melts? Where does it go?
Mixes with the water.
Mixes with the water?
Water
Okay.
with water.
All right, and then just answer this one in your notebook. What do you think would happen if we used salt water and non-salt water for the blue and red instead of cold and hot? Maybe we'll come back to this and try it another day. Thanks for all your help. It seems like we have more questions now probably than we started with. So maybe there's more investigating we can do.